Hello everyone, I'm Frank and welcome to Frank Puzzles. And this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum. And there's a lot of really smart people there. Today's puzzle is called Modular Islands by Jonesy. And here are the rules. Hello, hi. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. Digits are grouped into modular sets. We have the mod 1 set. It should be 1 mod 3 because the first digit is the remainder in front of the mod. The mod is the second part, and then the last digit should be what it's divided by. So these are all one mod. These are mod 3 sets. We have 1 mod 3, which is 1, 4, and 7. We have 2 mod 3, which is 2, 5, and 8. And we have 0 mod 3, which are 3, 6, and 9. So I disagree with this saying that these are mod 1, mod 2, mod 3. That's distinctly counter to how the modulo nomenclature works. So I feel like this would actually be a detriment to basically not comment on this. So again, these are 1 mod 3, 2 mod 3 sets, and 0 mod 3 sets. They are not mod 1, mod 2, or mod 0. Anything mod 2 would be basically anything divided by 2. Anything mod 1 would be anything divided by 1, so you only have 0 mod 1 if you actually ever had a situation with that. Anyways, sort of a pet peeve of mine, but just something that I wanted to clearly explain so that people hopefully don't continue describing these sets in the incorrect manner. Anyways, a digit placed in a circle indicates the size of the orthogonally connected group of cells that all contain digits from the same modular set as that digit. So a digit placed in a circle indicates the size of the orthogonally connected group of cells that all contain digits from the same modular set as that digit. So, first of all, what is an orthogonally connected group? It's a group where you can go from any cell in that group to any other cell in that group just by going through edges, excuse me, all while staying within that group. So as an example, you could have something like an orthogonally connected group like this. I need some water. You can go from any cell in this orthogonally connected group to any other cell in this orthogonally connected group just by going through edges, all while staying within the region. Actually, let's just use this one. So this would be a valid orthogonally connected group if you can go from any cell in the region to any other cell in the region just by going through edges while staying within the region. So for example, to get from here to here, you just follow these edges here and you would be able to get there. This would be an example of a region that is not orthogonally connected because to get from this cell to any of the cells in the region, you cannot just go through edges while staying within the region. You would have to go through a corner, or they would go through an edge, but exit the region, which is not allowed. And remember, these are the same modulo set, which would have to be either, if you're 1, 4, 7, it would be all 1, 4, and 7s here. If it's 2, 5, and 8, these would all be 2, 5, and 8, etc., etc. So the digit in the circle, if this were the case, this would have to be, if this were the actual region, it would be 6 here. if this were the region, this would have to be 7, because the size of the orthogonally connected groups of the same set are 7. No group contains more than one circled cell, and not all groups contain a circle. So that means we could have just an orthogonally connected group here, but we don't have to have a circle with it, essentially. And digits separated by a white dot must be consecutive. So for example, if this were, say, a 6 here, this would have to be 5 or 7, because the only digits which are consecutive with 6 are 5 or 7. And these need to be consecutive because there's a white dot between them. And have fun. We will try. Those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. Every group has one circle at most. So the group with this circle cannot be in the same group as these two, because they have to be, they cannot, again, be in the same group. Oops. Because then they would have, that group would have 2 circles, which is not allowed. So let's draw the boundaries. This has to be a separate boundary here, which means it's of size 1. So this is 1, and this must be 2 because it's consecutive with 1. So we have size 2 region here of the same set. We'll make this, so 1 mod 2 will make red, 1 mod 3 will make red, 2 mod 3 will make yellow, and 0 mod 3 will make blue. This digit must go out there, so this has to be at least greater than 2. So these two have to go at least out here and out here. This cannot be less than 2. So this has to continue out here. So we have 3 digits here. You cannot get a 4th digit here. This must also be at least 3 digits, but it can turn. So this is only 3 at most. It cannot go 4 here because every set is at most 3 digits in every row or column. So this has to be 3 of the same. It cannot be yellow, it cannot be red, it must be blue. And this must be 3 in size. That means this cannot be less than 3. It has, and it can't, but we can only have 3 of the same set in the column. So it must go this way. So we know this. We don't actually know if that's a boundary. It could go here and then here. That is possible. Oh, we don't. Okay, so... Okay, that's not necessarily true. We know these have to be the same set. So they cannot... Oh, they can't be red, can't be yellow. So this does have to be blue. But potentially this could exit... No. Yes, this could exit out that way. This is not guaranteed. So this is either 3, 6, or 9. So we have 3, 6, and 9 because those are the 0 mod 3 sets. This has to be a different set because we already have all 3 of the 0 mod 3 sets in column 1. This is 5 or 8 here. Interesting. Okay, so this is guaranteed to be the same set as this. It cannot be blue, it cannot be yellow, it has to be red. So this is guaranteed to be red. Therefore, none of these can be red because we have 3 reds already in the box. So this must go out this way then. So that's guaranteed, which means this is closed off here as a orthogonally connected group. This is blocked here, and this is blocked here because we can't have any more reds. So it must go red here. And this is 4 or 7 here. This has to be a 3 here. And this can't be 3 here. To be consecutive, if it's 4, it's with 3 and 5, so it'd have to be 5. If it's 7, it's 6 or 8. We don't know which. Okay, so this would be 4 or 7. Also, this would have to be 1 because of the 4-7 pair in the column, eliminating 4 and 7 as possibilities, and it still must be a 1 mod 3 set. This is 4 and 7 here. We don't know where it goes to. This has to be a combination of yellow and blue, so these are different sets here. So this must go out this way. We'll mark that as pink. Actually, we'll make it orange. Okay. This is consecutive with 6 or 9. So this has to be either 5, 7, or 8 here. Interesting. Could be just 3 direct that way. It has to exit out to be orthogonally connected. And it has to have either 2 in this direction or and it can't be 6 or 9, so it's not blue. And if we try to have red, it would guarantee 4 reds in this box, which is not allowed because every set is only 3 digits in size. So this must be yellow. So we have 5 and 7, 5 and 8 here, consecutive with 6 or 9. You could just have 3 straight digits here. These are okay, so these are a combination of blue and yellow. Sorry, not blue and yellow. Yellow and red in column 1. In column 2, we have a combination of blue and yellow. Okay. This has to be, well, we don't know. This does not have to necessarily go out. This does, though, because it's size 5 at least. So this is blue or yellow. This is size 5, so it's guaranteed to go out either this way or this way. So this is at least size 5. It's guaranteed to go one of those two. Therefore, if this were yellow, it would be part of the same orthogonally connected group, which is not allowed. So this cannot be yellow. It must be blue here. So this is 3, 6, or 9 here. So it either goes yellow, yellow, yellow that way, which would force yellow, yellow to go that way to get 5, or yellow, yellow that way to get 5. Or it's yellow, yellow, yellow that way. Anything with a white dot between them must be different sets, because the same set obviously can't be consecutive with a digit that's in the same set. Also, they must be different from any other circle that shares an edge with it. Okay, remaining digits in column 1. We have 2, 5, 8, and 4, 7. Remaining digits in column 2, we have 3, 6, 9, and 5, 8. Can this ever be yellow? Yeah, it could. You could have 2 yellow here, and then going yellow around that way. It's possible. This is either 5, 6, 8, or 9 here. So we have a guaranteed 9 in one of these 2 cells. Wait, why can't this be 9? Never mind. This could also be 9. No, it's 9's not consecutive with 7. That's the reason why it can't be 9. So we have a guaranteed 9 here. Hmm. This has to be at least 3. That's pretty broad, though. Hmm. Hmm. Okay. Oh, this can't be 5 or 8. That would force this to be orthogonally connected region with this, but it's already only of size 2. So this has to be 6. So this is 6, which makes this 7 to be consecutive with it. That makes this 4. That makes this 9. This is 6 here. This is then blue. So this has to be yellow. Not 6 or 9. It's 5 or 8. We cannot go 3. Okay, we are done that way. So this has to go down. Because if we try to go up, the problem is that, yeah, this is blocked here because we already have 3 blues in that row. So it has to either go up or down, and if we can't have 6 going this way if it's just this way. So if we have this as another region, this would then be only 4 in size, which doesn't work. So this must be blue here, which means this is another region here. We only have one more here, so we have to go that way. So this is blue. This is 7 in size. That must be red then, because we have to have 7 here. That means we have 3 reds in box 4. This cannot be red. It's yellow. So red is blocked there. Red has to continue on here to get 7 reds. 1, 2, 3, 4, 5, 6. And then it can go either there or there. We're not sure which. Blue, we have 3 blues in column 4. This cannot be blue here, so that's going to be a boundary there. This can't be blue, and it cannot be yellow. It has to be red. Because this is size 2, this is size 6, and again, we can't go that way because we have 3 blues there. Then we must go blue there. And this is a different region than this. So this is boundary here. We have one of these is blue then. We don't know which. Okay. These digits are consecutive with 3, 6. So this has to be 9 here. This must be 3, 6, which is consecutive with this digit. So it would be 2, 4, 5, or 7 here. Which means this has to go at least this way as a region. It cannot be 4 and 7. If this is 4 and 7, this is red. We'd have 2 reds here. There would be no more reds here, and this would be size 2, which obviously doesn't work. So this has to be size 2 or 5 here. So these are yellow. It could go out this way. We don't know. Or it could stop here. We don't know that either. This is red. This is blue or yellow here. We don't know. Where is 2 in this box? Cannot be here because of... Actually, could be here. Never mind. 2 has to be one of these 2, though. This cannot be 4 or 7. It's 2, 5, or 8, which means it goes that way. So it has to have 5 digits, so it must continue on that way. Cannot be red, so that's yellow. We have 3 yellows in column 1, so these must be both red. We must continue on to yellow here because we need 5 yellows to be in the same region. It could be these 5, and that's it. That's possible. No, 4, 7, 8. No, 4, 7, 7 here. No, 3, 6, 9 there. This is 4 or 7. This is 4 or 7. Remaining digits in column 1, sorry, column 3. We have 1, 2, 3, and 9. And this can't be 1. It's 2, 3, or 9. One of these is going to be a 1 here. This could be 8 also. Oh no, it's consecutive with 3 or 6. I keep forgetting that. 6 is consecutive with 5 out of 5 or 8, so that's 5. No 5 here, no 5 here. This blue must go out this way because it's not going to be, it can't go out here, it can't go out here to get to greater than 2 as a region. So this must be not 2. It's 3 or 9. Well, now it can't be 6 because of 6 in the box. So we have a 3-9 pair here, which eliminates 3 and 9 here. This can't be 6, it's 8, and is yellow. So the yellow is done as a region for that orthogonally connected region. This cannot be yellow here. This is too blue. This can't be yellow here. So this is red or blue here. We're not sure which. 5 and 8 eliminate 5 and 8 here. So that's 2, which makes this 8, which makes that 5. No 5 or 8 here. It's 3, 6, or 9. No 2, 5, 8 here. It's a 4, 7 pair. This can't be 2. So that's 1, 3, or 9 there. Okay. What else do we have? This is very likely 3, but we don't know that for certain. Can this be 5? It certainly could. One of these is blue. We're not sure which. One of these is red. We're not sure which. Okay, so since one of these is blue... Oh, it can't be blue here. We have 3 blues in the row. So this must be blue that way. We have 3 blues in the central box, so that cannot have any more blues. Red has to go this way to get 7. 1, 2, 3, 4, 5, 6, 7. So this has to go red that way. That means this must be 3 at least, so this has to go blue that way, which is not 1. We have a 3, 9 pair here, which eliminates 3, 9 in the rest of the column. So this is 1, 2 as a pair here. This red is done as a region. So we have that. Blue is done as a region. So this cannot be blue or red, and in fact, these all have to be yellow, because those are the only remaining set there. And this must be 2. This has to be a 5, 8 pair here. This can't be red, it can't be blue, it must be yellow there. None of the rest of box 8 can be yellow, so that's blue or red. We have 3 yellows in column 5, which eliminates yellow in the rest of the column. So this is not yellow. This could be blue or red here. We don't know. Okay. This digit, if it's red, can work if it's a 1. Otherwise, it's 2 in size. Interesting. So this has to be red or yellow, and if it's yellow, it has to be 2 because of the 5, 8 in the row. If it's red, it cannot be 4 or 7. The reason why we know that is if it's red, there are no more reds in the box available because we have 2 of them already here. So these would both be yellow. We would have 3 reds in the row here also. So then this couldn't be red either. So none of these would be orthogonally connected. So this is guaranteed to be 1 or 2. If it's 2, that means it would have to be yellow going that way. So remaining digits in box 5 are yellow and red. Can this ever be red? Then that would force these all to be yellow, and it would be size 2 with 3 cells in it, which is not allowed. So this cannot be red here. This must be yellow. In fact, well, we don't know. This is 3 or 6 here. We have 3, 6, 9 here. We don't know which. So this must be 2, 5, or 8 here. 6 eliminates 6 in the rest of the row, so this can't be 6, that's 3, which makes this a 6. This can't be 3 or 6, it's 9. This can't be 3 or 9, it's 6. 6 is only consecutive with 5 out of 2 and 5. So that's 5, this is 8, that's 5. Yellow has to go out this way. So we have 1 yellow here. That's 3 yellows already in the box, so this can't be yellow, it's blue or red. This can't be yellow, it's blue or red. So yellow has to continue out that way because otherwise it's going to be too few digits for the region because that would be 5. That's 3 reds in row 2, so this cannot be, sorry, 3 yellows in row 5, so this can't be any more yellows. So it goes either here as a yellow or here as a yellow. This has to be 2, 8 as a pair, which leaves this as a 5 here. Remaining digits in row 2 have to be red. So this cannot be 5, 6, or 9. Cannot be 8. It's 3 with or 4 or 7. Okay. This digit can be it's blue or it's red. So it could be 1, 3, or 7 here. Where is the 1 in column 4? It cannot be any of these digits. It has to be one of these two. So this cannot be 1 here. This is 2, which means it's not red. It's yellow here. That means these can't be yellow because we have 3 yellows in row 5. And we can't have yellow going here because then that would be size 3. So this must be a red here, and this is size 2 as a red, and that's done. So we have boundary here, we have boundary here, boundary here. This is yellow, so this is by itself. Cannot be 2 here, cannot be 5, so it must be 8, which makes this 2, which makes that 8. This can't be 2 or 8, it's 5. Cannot be yellow here. Remaining digits in row 4 can be 2, 8, 4, or 7. And it cannot be yellow because we have this is already size 2. So it has to be red. And 4 and 7. So this is red, this is yellow. We have a 4, 7 pair here, which eliminates 4, 7 in the rest of the row. So these are both yellow here. These cannot be the same sets. But we could go down here. We don't know. This is 1, 4, or 7 here. This has to be... where is the 1 in box 2? Can't be here. And these are done already, so this must be 1, which is a red. So this can't be red. But it could be yellow or blue. Remaining digits in row 3 are 2, 3, and 7. So 7 cannot be here. And this is 2 or 3. Remaining digits here are 1, 4 as a pair. This is 3, 4, or 7 here. Remaining digits in row... in row 1 have to be 6, 8, and 9. Okay. So, this, to be larger than it, has to go out here. And the problem is, if this were red, the problem is it would be stuck here, and that would be size 1, which is not allowed. So this cannot be red. This must be blue. That means we have 3 blues in box 2, so this cannot be blue here. It's red. Therefore, this must be a 3 here. This cannot be 3 here. This is size 3 as a region, so it must be those 3 cells. That means yellow has to go that way. And that's done. So these are done as regions. Oops. Ugh. These are done as regions. So this must be 6, 9 as a pair, which eliminates 6 and 9 in the rest of the row. So this is 8 here. This is 2 here. These can't be 2. This is size 4 as a region, cannot go that way. It has to go all 3 there. This is then blocked by this cell because we have 3 red cells in the column. So that's no longer part of the region. These can't be part of the region either. We only have access to 3 reds in, well, it could be all 3 reds. Okay. This is done as a region boundary. So this is yellow. This can't be 8, so that's 2, which makes this 8, which makes that 7 to be consecutive with 8. That means this can't be 7, that's 4, which makes this 7. No 7 here. This must be 1, 4 as a pair. Remaining digits here have to be blue because we have 3 yellows and 3 reds. So these are boundaries here. This is size 5. This is boundary here. We know that. This is already boundary there. These cannot be yellow, so that's boundary there. This is size 7 as a region, so it cannot go blue here. This is red. You cannot have this region have 2 circles, so this has to be blue. Because this has to be red, red here, so no red here. So this is blue and blue here. This is a 3, and this has to be size 6 or 9 here. Interesting. This is 3 and 9 as a pair. Remaining digits in row 6 have to be 5 and 6. Okay. This is size 6 or 9. It could be either one. This is consecutive with this, and it's red. Cannot be yellow because of the 3 yellows in the row, so this is blue. This blue has to be orthogonally connected to this because we have, this is done as a region. This has to be 4 and 7, which is consecutive with 3 and 6 here. Border here. 3 eliminates 3 here. So this is a 6. We have 3 blues already in row 9. So this cannot be blue here. That's done as a border then. So this has to go here. That's blue. We have, yeah, this is definitely border there. So one of these is blue here. Remaining color in column 7 is a yellow. So that's yellow. We could go blue here, blue here, blue here for 9, potentially. This is 1, 4, or 7. We have 1 blue here and 1 red here. Interesting. If this were blue, that would mean there's no more blues in the box, so it can't orthogonally connect to any of those. It would have to orthogonally connect to one of these. It would have to then go here, but that would be size 4. So this cannot be blue. It's red, which eliminates red in the rest of the row. Cannot orthogonally connect to any of these cells here. It could connect to orthogonally to some of these cells here, But then that would be size 3 at most. So it can't be there. So this must be 1. And then this is orthogonally not part of any region. This is blue, so this cannot be, this has to be boundary here. This can't be red because that would be orthogonally connected to the same region. So it's yellow, which means this, we have 3 yellows in column 9. This can't be yellow, it must be blue. And this is size 6, that's 5, which is yellow. So that's not orthogonally connected as a region. So then this is only size 6. So this is 6, that's 9, which eliminates 6 here. 9 eliminates 9 here, so that's 6. This is blue, and it's, sorry, it's yellow, and it's 5. This has to be 3, 6, and 9. Cannot be 6 because of 6 in the row. 5 eliminates 5 here, so that's 8 and 5 there. 1 eliminates 1 here. Where's the 1 in box 8? It must be here. Since this is 1, this can't be 1. That's 2, which makes that 1. So this is yellow, and this is red. So we have boundaries here, boundary here, here, and here. We need a 2 and an 8. This can't be 2 or 5, so that's 8. Whereas 2 in row 9, it has to be here, so that's yellow. So those are all the yellows, and these must be reds then. So these are boundaries there, boundary there. 1 eliminates 1 here, so that's 4 and 1. 4 eliminates 4 here, so that's 7, which makes this 4. 7 eliminates 7 here, so it's 3 and 7. Therefore, that's the blue, and this is the red here, so that we have boundary there. And then we have all the boundaries now. And now it's just a matter of figuring out what digit is where. Okay, so let's just make sure. This is size 1 as a region, 2, 7, that's 6, 7, 6, 5, 3, 1, 7, 2, 5. Oh, this is size 3. So that's 3, which makes this 9, which makes that 9, and makes that 3. That means this can't be 3, that's 6. This can't be 3 or 6, it's 9, which makes that 3. 6 eliminates 6 here, so it's 9 and 6. 9 eliminates 9 here, so it's 3 and 9. So these digits are consecutive. And this is size 6, and this is size 1. So that's satisfied there. Therefore, these are consecutive, and therefore cannot be 4. 4 is not consecutive with 6, so that's 7, which makes these 4. 4 eliminates 4 here, so it's 7 and 4. That means this can't be 4, it's 1 and 7. 4 eliminates 4 here, so it's 7 and 4. And 4 eliminates 4 here, so that's 1 and 4 there. Very cool, actually. I really enjoyed this exercise. This was a very interesting way of how the modular lines work, or the modular islands worked. Again, I would just say that, you know, let's get the right actual nomenclature for the modulo naming. Other than that, like, this is definitely a well-developed puzzle. It flows very well throughout. And overall, just a fun puzzle. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.